Today I am discussing properties of complex number. So properties of complex number. Here are some properties of related with conjugates. So what is Z? We take Z is equal to A plus iota B, and Z bar is equal to conjugate of the complex number Z, which is A minus iota B. So some properties of conjugates with related with this complex number. Here the first number is Z bar, and then again bar is equal to Z. So how we can prove this? We know that we have taken Z is equal to A plus iota B. So Z bar will be A plus iota B bar is equal to A minus iota B. Then again we take bar. So this will be A plus iota minus B bar. So this will be again minus A minus iota minus B. So minus minus it will be plus A plus iota B, which is Z. So this is the first property of conjugate. Now the second property is that Z plus conjugate of Z plus conjugate of Z is equal to 2 of real Z. 2 of real Z means just A is called real Z and B is called imaginary Z. So real Z means 2 into real, 2 into real Z means 2 into A. So we have to prove this. So we have taken Z equal to A plus iota B, and Z bar is equal to A plus iota B minus iota B. So Z plus Z bar is equal to A minus iota B. So iota B cancel each other. Here it will be 2A. So A is real number, real of the complex number, which is real Z. So this will be 2 into real Z. No imaginary number here is. Now the third property is that Z minus Z bar is equal to 2 iota imaginary of Z bar. Imaginary of Z bar means this, which is minus B. Imaginary of Z bar is minus B. This is just Z, not Z bar. So imaginary of Z is equal to just B. So how we can prove this? Z minus Z bar is equal to A plus iota B minus A plus iota B. So A cancels each other. This will be 2 multiply I iota minus B. So B is imaginary of Z. So this will be 2 iota imaginary Z. The fourth number is if Z is equal to Z bar for any complex number, imaginary of Z is equal to 0, then Z is purely real. So with this, given that Z is equal to Z bar, it implies that A plus iota B is equal to A minus iota B. For both sides, A cancels each other, and we will have 2 iota b is equal to 0, which implies that b is equal to 0. Means that imaginary of z is equal to 0, so z is purely real. It implies that z is purely real. So it is both sides. This implies true for both sides. Now, fifth number, if z plus z bar is equal to 0, then z is purely imaginary. Means imaginary of real of z is equal to 0. So how we can prove this? Z plus z bar is equal to 0 implies that a plus iota b plus a minus iota b is equal to 0. So iota b cancels each other, and we have 2a is equal to 0 implies that these are both sides implies that, so a is equal to 0 means real of z is equal to 0. So both sides implies that z is purely imaginary. And fifth and the sixth is z plus z1 plus z2 bar is equal to z1 bar plus z2 bar. So here we have to know that what is z1. We are taking z1 is equal to a1 iota b1 and z2 is equal to a2 iota b2. z1 is equal to a1 iota b1 and z2 is equal to a2 plus iota b2. Now, if we take z1 plus z2, then this will be the sum of the reals of the two complex numbers. This will be a1 plus a2, and then iota, sum of the imaginary of the two complex numbers. This will be b1 plus b2. Now, if we take the conjugate of this complex number z1 plus z2, and it will be just negative sign comes before the iota. This will be a1 plus a2 minus iota b1 plus b2. Now if we rearrange this, then this will be a1 minus iota b1 plus a2 minus iota b2. So this is conjugate of z1. Conjugate of z1 is a1 minus iota b1, and conjugate of z2 is a2 minus iota b2. So this is z1 conjugate of z1 plus conjugate of z2. So in this way you can prove this. Now the seventh number. Seventh number is z1 minus z2. Conjugate of z1 minus z2 is conjugate of z1 minus conjugate of z2. So here we have taken the same. z1 is a1 plus iota b1, z2 is equal to a2 plus iota b2. So here z1 minus z2 is equal to real subtraction of reals or minus of reals, a1 minus a2 plus iota b1 minus b2. So its conjugate will be a1 minus a2 minus iota b1 minus b2. Now if we rearrange this will be a1 minus iota b1 minus a2 minus iota a2 minus will be minus a2 minus plus, and then again it will be minus iota b2. This is the conjugate of z1, conjugate of z1 minus conjugate of z2. This is another proof. Number 8 is that z1 multiply conjugate of z1 is equal to real of the complex number z whole square plus imaginary of complex number z whole square. So here number 8, z1 z bar, so z is equal to a plus iota b, and z2 is equal, z bar is equal to a minus iota b. If we multiply this will be a square minus b square. So iota square is equal to minus 1. This will be a square minus 1 b square. So it is equal to a square plus b square. So a is real of a, real of z is this whole square, and b is imaginary of z. This is imaginary of z, its whole square. So in this way we can prove the number 8 property. Number 9, conjugate of z1 multiply z2 is equal to conjugate of z1 multiply conjugate of z2. So 9 number, z1 multiply z2 will be a1 plus iota b1 multiply a2 plus iota b2. If we multiply this will be a1 a2 minus iota multiply iota square is equal to minus 1. So b1 b2, and then take if we take common iota, then it will be a2 b1 plus a1 b2. Now if we take conjugate of this, then it will be z1 z2 conjugate, it will be a1 a2 minus b1 b2. This will be minus iota a2 b1 minus a1 b2. Now if we rearrange again this, we will take here minus iota plus iota square minus 1. This will be a1 a2 minus iota a1 a2 b1 minus plus iota a1 b2 plus iota square B1, B2. If we take common A1, A2 here, then under bracket it will be A1 minus iota B1, and here it will be iota B2 common, then under bracket it will be plus actually, not minus. So this will be minus actually. This will be minus iota B2 A1 minus iota B1. This will come A1 minus iota B1 under bracket A2 minus B2 under bracket. So these are the conjugate of Z1 multiply Z2, conjugate of Z2, the conjugate of Z1 multiply conjugate of Z2. So this is our property, that conjugate of Z1, Z2, Z2 equal to conjugate of Z1 multiply conjugate of Z2. So these there are 9 properties, and number 10 property is that it is also very easy to prove. Anyone can prove this, that Z1 by Z2 bar is equal to Z1 bar by Z2 bar, or conjugate of Z1 by Z2 is equal to conjugate of Z1 by conjugate of Z2. So one may try to find out this is true or not. Very easy to prove this. Thanks for watching.